the standard normal distribution. So in previous videos, we've been looking at the normal distribution, what it is, how to calculate probabilities, how to calculate variable values, and how we can use the 68, 95, 99.7 rule. This one is going to cover the standard normal distribution, which is a special case of the normal distribution, which has a mean of 0 and a standard deviation of 1. So it means our function drops out. Instead of having the 1 over sigma root 2 pi and everything, it drops out to be 1 on root 2 pi e to the negative 1/2 z squared. Now I use z for the standard normal. It's always using the letter z as a variable for standard normal, as opposed to using x for any other variable. And what this does is allows us to compare different data sets. So a very good example of that is when we're doing study scores at end of year 12. You have different studies all getting different means, different standard deviations. How do you compare rankings against one another? It's the same with any kind of ranking system, whether you're doing the study scores or whether you're doing university scores, whether you're doing countries ranking in terms of the PISA results academically, but whether it's economic or anything like that. How do you compare two different sets of data to make sure it's fair? The only way to do that is by using a standard rule, and that is where the standard normal distribution comes in. And the way we convert it between the two is by using this conversion factor here. Essentially, all we've done is in our rule of our function at the top right-hand corner here, we've replaced x minus mu over sigma with z. It's transformations back to a mean of 0, standard deviation of 1. So this is always true for z, and any other variable has this, where we don't know the mean at the moment or the variance at the moment the way I've written it, but you'll be given that in the question, or sometimes you're asked to find it and work backwards. That'll come in the final video on the normal distribution that I'll be doing on problem solving with it. Now you might have heard the word z-scores before. That's what this conversion gives you. It gives you a z-score, and the value tells you whether you have a value larger or smaller than the mean. So if it's positive, it indicates you got a value bigger than the mean, because remember, bell curves like this, like that. We have the mean at 0 because the standard normal is mean at 0, and that's going above 0, which means, well, the mean is the average, isn't it? Remember, average and mean mean the same thing in our case here. So it's positive if it's above the mean somewhere. If it's negative, it's indicating it's less than the mean. So let's have a look at a couple examples. The mean and standard deviation of a typical IQ test is given by 100 and 15 respectively. So we got x is normally distributed with a mean of 100, and standard deviation is 15, so it's variance, so 15 squared for your variance. Find the z-score of a person who scored 120 on the IQ test. Well, find the z-score. Z is going to be x, and that's the variable value, which our case is 120. There's our x. So 120 minus the mean of 100 over the standard deviation of 15. And that comes out being 20 over 15, which is 4 over 3. Now, on a tech enabled, that's where you leave it. Tech free, sorry, where you leave it, unless you've been asked for decimals, in which case it'll be 1.3 recurring, but they'd ask you to round it off. But unless asked, leave it as 4 over 3. Part B, a person achieves a z-score of 0.12 on the IQ test. Calculate their raw score. Okay, so 0.12. This is our z value. We are now being asked to find the x value. We're asked to find this equivalent here. So let's do that. So z value is 0.12. The x value we don't know. We're going to try to solve for that, but we do know mu and we do know sigma. So we multiply across 15 times 0.12. You can do 15 times 12, which comes up with 180. And we have 0.12, so you have 2 decimal places, so it's 1.8 there. So therefore, the score for the IQ test was 101.8. So this person's Z score was 1.33. Theirs was 0.12, so you'd expect our first case to have a higher IQ, and it does. They had 120, second case, only 108. When they're in the standard realm for population, it's just they're a bit low. But this time we got a different person doing a different IQ test, and this has a mean of 90 and a standard deviation of 5. So how do we compare whether this person has a higher IQ or not? So which of the 3 people have the greatest IQ score? Well, I know that person A has a higher one than person B. We've already seen that Z scores, 1.33 versus 0.12. What I want to do is find the Z score on this last one, because remember, we're comparing Z scores. So we have 3 different distributions happening here. They are all bell curves. This bottom one has a mean of 0, but these other 2 have a mean of 100 and a mean of 90. And there's no way to evenly compare these 2 because the numbers are different, scales are different, everything, unless we both convert them into here. And what you'll find is there is equivalent position. There might be the person who got 120 there, 120, has an equivalent position here at the 1.33 that we calculated. The person who had the 101.8 was about here, 101.8. They were really close about there at 0.12. So you can see the green is ahead. Now I'm going to try to convert from this one into this one to find out what happens with this last guy or girl, whoever it might be. So we're going to use our Z score. So Z equals X minus mu over sigma. Z we don't know. X we know is 95. So 95 minus mu of 90. There's our mu. Over 5 standard deviation. That gives you 5 over 5, which is 1. So if I mark in on this curve over here, on the 90 curve, this one here, they scored 95, it's about there, 95. How does that compare into this distribution down here? Well, they got a score of 1, which is going to be there. A score of 1. So the question then is, who had the highest IQ score? Well, the highest IQ score was from the person in A. They had the highest Z score. Of 1.33 or 4/3. And that is how you use a standard normal to convert between different distributions and compare them. Now, normal distribution all combines together. So often you're asked to use a standard normal with a bit of the 68-95 rule, with a bit of calculate the variable, and that's all combined together in the problem solving idea, which is a different video. But that's how you use the standard normal distribution.